All right, let's dive into one of the absolute cornerstones of working in Unity. We're going to pull back the curtain on the secret, predictable timeline that every single component in your game follows, from the moment it's born to the moment it's destroyed. Getting a handle on this is, well, it's everything if you want to build solid bug-free games.
So, what is this secret life I'm talking about? Well, it's a built-in sequence of events, a script that Unity itself follows for every script you write. The best way to think about it is like a predictable story with a very clear beginning, a middle, and an end. Once you learn the plot, you can write code that just works, every time.
And hey, don't just take my word for it. This is a direct quote from the prep material for Unity's official programmer certification. They're basically telling you this is the single most important piece of theory you can possibly learn. Why? Because when you really get this, a whole class of incredibly common, frustrating bugs just disappears.
Okay, so here's the official textbook definition. The monobehavior lifecycle is that specific, guaranteed order that Unity calls all these built-in functions. From creation all the way to destruction, this order is set in stone, and the second you know it, you gain precise control over when your code runs.
So let's start where every story does, at the very beginning. We're talking about the initialization phase. This is all about the game object waking up, getting its bearings, and preparing for action before the player ever sees a single frame.
In this first act, you've got three main functions you'll work with: awake, onEnable, and start. Awake fires off first, the second that object loads, even if it's turned off. Then comes onEnable, which gets called right after awake if the object is active, and it gets called again anytime you switch it back on. And finally, you have start, which runs just once, right before the game's first real update.
Now, if you only remember one thing about initialization, let it be this. It's a super simple way to think about it. Awake is for getting your own house in order. It's for finding your own components, setting up your own variables. Start is for talking to your neighbors. You use it to interact with other objects, because you're guaranteed that by the time start runs, all of them have already finished their own awake prep work.
And this is why that works. Unity literally promises you that all awake functions in your scene will run before any start functions begin. That's the key to the whole thing. It means you can grab a reference to another script in awake, and then in start, you can actually use that reference, totally confident that it's ready to go. This simple rule prevents a huge category of errors.
Okay, initialization is done. Our object is officially alive and ready. Now we get to the main part of its life. The update loop. This is the heartbeat of your game, where all the dynamic, frame-by-frame action really happens.
So, every single frame your game is running, this exact sequence plays out, over and over. First, Unity handles all the heavy physics lifting in a function called FixedUpdate. Then, it runs all your general game logic, your input checks, stuff like that, in Update. And finally, it does any last-minute cleanup or adjustments in LateUpdate. This order is your best friend. It's consistent and totally predictable.
The trick, of course, is knowing which one to use and when. FixedUpdate runs on a fixed timer, completely separate from your frame rate. That makes it absolutely essential for smooth, reliable physics. Update, on the other hand, runs exactly once per frame, so it's perfect for things that need to be super responsive, like checking if the player pressed a button. And LateUpdate, it runs after all the update calls are done, which makes it perfect for things that need to react to what just happened, like a camera trying to follow a moving player.
Okay, quick pop quiz. Let's make this practical. You've got a character, and their movement is driven by Unity's physics engine. You also have a camera that needs to follow them smoothly. Based on what we just covered, which update function goes with which script? Think about it for a sec.
You got it. You put the character's movement code into FixedUpdate because it's physics-based. It has to be consistent. Then, you put the camera's following code in LateUpdate. This guarantees the camera only moves after the character has finished its physics step for that frame. And that little trick is how you completely get rid of that awful, stuttery camera jitter. So we know the right order. But what happens when we get it wrong? Because understanding this life cycle isn't just some abstract theory. It's your #1 weapon against some of the most common and maddening bugs you'll ever encounter in Unity. Oh yeah, the infamous null reference exception. If you spent any time at all in Unity, you've seen this error. It's what happens when you try to use a component that your script hasn't found yet, or that doesn't even exist. It's basically like trying to call a friend, but you never actually looked up their phone number. And here's how the Lifecycle just completely solves it for you. You use awake to find and assign all your references.
Then you use start to actually do stuff with them. Because you know the guaranteed order, awake, always comes before start, you know for a fact that the reference will be there waiting for you. It's a simple discipline that prevents a world of pain.
Now this next one is a little sneakier. It's called a race condition. This is what happens when you have two different scripts racing to change the same variable, and the final result depends on whichever one gets there first. This can lead to some really bizarre, unpredictable behavior that's a total nightmare to debug.
But the monobehavioral lifecycle is like the ultimate referee. It blows the whistle on the race before it can even start. By putting your code in the right lifecycle function, awake, start, update, late update, you are explicitly telling Unity, hey, this code has to run before that other code. You take control of the timeline. You make the unpredictable predictable. The race is over.
Okay, we've seen our object get born. We've watched it live its life frame by frame. And now we've come to the final act, the end. Doing a proper cleanup is absolutely crucial for preventing memory leaks and making sure your game stays performant.
For the end of life, you've got two key functions, onDisable and onDestroy. Think of onDisable as temporary. It gets called whenever you turn an object off. It's perfect for pausing things or unsubscribing from events. OnDestroy, however, that's final. That's the last call you're ever going to get before the object is wiped from memory for good. It's your last chance to release resources and clean up your mess.
So let's boil it all down one last time. The lifecycle is a predictable timeline that you control. Just remember, awake is for you, start is for the team. Use the right update for the job. FixedUpdate for physics, update for logic, late update for follow-ups. Mastering this order is your shield against null references and race conditions. And please be a good citizen and clean up after your objects using onDisable and onDestroy.
Look, understanding this lifecycle really does change everything. You go from just writing lines of code to being an architect who can orchestrate the entire flow of your game. You're basically in control of time itself. So the only real question left is, with this power in your hands, what are you going to build first?